All right, I hope everyone can see me and hear me all right. I saw the message from Justin over in the chat that I think we're ready to get started. So thanks everyone for joining today. My name is Doug Petkanics. I'm one of the founders of the Livepeer project. I'm excited to be here giving a workshop during this hackathon hosted by CoinList and NuCypher. What I'm gonna do today is give a quick overview of the Livepeer project, and kind of after the overview and demonstration, I'll talk about kind of what can be built on Livepeer and how you might use the network or build something for the network. And then finally, kind of propose a few ideas related to hacking on something related to NuCypher and Livepeer, since they're kind of the sponsors of this hackathon. First of all, I just want to apologize. I have a little bit of a kind of a allergy going on with a cough, so if I'm coughing a bunch, I apologize in advance, but hopefully we'll power through this. And if anyone has questions as we go, I have the chat window open here in the chat, so feel free to dump them in there, or if you want to unmute yourself and jump in, I don't mind that either. So let's get started. So first of all, as I mentioned, I'm the founder of a project called Livepeer. So what is Livepeer? Livepeer is basically infrastructure for video streaming and video applications. And what I mean by saying that it's infrastructure is that it's used by developers and applications that want to kind of stream video at scale in order to power those applications. So Livepeer is not a YouTube replacement or a Twitch replacement, but apps like YouTube or Twitch or decentralized versions of them, or other centralized applications using video that look like them or have different takes on those, need to use infrastructure to encode their video and to stream their video and to reach many users on the network, many of the users of their applications. And Livepeer under the hood really powers that infrastructure. So our users of Livepeer are not necessarily individual broadcasters or content creators, but they're developers who are building applications and need to make video work in those applications, and in particular, need to make video work at scale. So that's kind of what Livepeer is. So we're actually a decentralized infrastructure project. And what that means is that rather than Livepeer, the company, hosting a bunch of servers that can ingest and encode video, anyone can run the Livepeer software and they can contribute their own computing power, their own bandwidth to encode video. And the users, the developers who are using this network, are not necessarily paying a company to do so. They're just paying the network in order to access this infrastructure. Here are a couple people unmuted there with some background noise. If you could mute if you're not talking, that'd be great. Thanks. Cool. So the way it works is that if you want to broadcast video, you can run a Livepeer node and you can send video into it. What the node does is it basically is running something called a media server, an open source media server, LPMS, and that knows how to speak video. It knows how to ingest the video in the different formats. It knows how to serve the video out to your users or to a content delivery network. And in particular, it knows how to do something called video transcoding. And what this is an HD video comes in, and what you need to do is you need to convert that video into all the different formats and bit rates so that it can be playable on every device at every connection speed, reachable by kind of every user across the planet. So I'm going to try and do a quick screen share here and kind of show you this in practice. Let's see, hopefully you guys can see my screen. And this is always risky, doing a demo of video while there's a video chat going on because it takes so much bandwidth. But what you see here is a particular stream of video being pushed kind of through the Livepeer network. And then down in the bottom here, what you see is, it's a 1080p HD video coming in, and it's being shown in very high quality, but that's not necessarily downloadable by people on cell phone connections with slower connection speeds. So it's being transcoded into a 720p, a 360p, and a 240p format at much lower data rates. And therefore, it requires much less data to deliver. Users at those lower speeds get a much better experience. And you as the end user watching this video stream may not necessarily ever notice this, but what the video players do is it kind of switches between these different renditions of video depending on your connection speed and your quality. And so I just manually switched it. It was probably hard to tell, but you're seeing it at a much lower resolution using much less data than you were before. And so if you're not a video developer, you may not necessarily care about this concept called transcoding, but it's super important as a consumer of video. So whenever you're watching Netflix or YouTube or video on Facebook or Snapchat or Instagram or anything, it's being transcoded to be delivered to you at the most efficient bit rate and in the format that your device knows how to play. And so here's a kind of working example of the Livepeer network being used live and in progress. One of the other benefits that we talk about is kind of cost savings. It's very expensive to use cloud providers to perform this service. We believe that in an open marketplace where anyone can run this software and put their idle compute on the network, we can create dramatic cost savings. And even though this is kind of an early demo and an alpha, these numbers serve as kind of a proxy for what kind of savings you're seeing. And this video has only been going on for a few seconds here, so you're not seeing huge numbers, but trust me, over minutes or hours of video streaming becomes very, very expensive. So stop my share there for a minute. That's kind of the quick overview of what Livepeer is and what kind of functionality it provides. Now, it's also worth noting as a decentralized project that we are built on Ethereum. So why are we built on Ethereum? What does a blockchain provide? It does kind of a few different things for us. The first is that it secures this network. If you're going to send your video into this network and you're going to let any random node encode that video, you need to have confidence that it's going to actually output the correct video and not output some malicious content or something that's not your video, or try and get paid for just outputting 0 bytes and empty video. And so blockchain actually provides this security backstop through a protocol we have where the nodes commit to the work they did using a hash. It can be challenged if anyone finds that the video is not encoded correctly. And then there's a protocol called TrueBit, which actually serves as the final backstop judge that can actually arbitrate whether this compute was carried out correctly. So the kind of blockchain provides the security and proof that this work is done correctly. It also settles payments across this open marketplace and this open network. So, broadcasters deposit ETH in order to pay, and that ETH gets split up amongst those who did the work and gets settled out to and then finally, so beyond kind of security and settling payments, there's also this crypto economic protocol that provides incentives for people to actually run nodes. So there's a Livepeer token. People who want to run nodes stake that token in order to provide security. That stake can be taken away or slashed if they cheat you. But they're also earning new inflationary Livepeer tokens. So they're actually growing their kind of stake in the network and earning the ability to do more work by kind of standing by, running this software, running these nodes, ready to participate. And so, those 3 pieces of functionality backed by Ethereum actually enable this to be an open marketplace, a decentralized network, allow anyone to compete to perform this work on the network, earn the fees and earn the business on the network. And so far, so good. The status of the project is that Livepeer launched on mainnet in May 2018, so almost a year ago now, and very much an alpha, but it's functional. It's been used to broadcast hundreds of events, mainly in the crypto and blockchain space, meetups, conferences, etc. We had 5 streams coming out of DevCon. We had a few streams coming out of some of the ETH hackathons, like ETH Berlin. The Ethereum Core Dev calls also co-stream onto Livepeer. This is all great usage for testing the network. It's not scaled usage where there's hundreds of streams concurrently, but we have a big release coming up called Streamflow, which kind of mitigates some of the blockchain congestion issues and will actually allow this to be used at scale. So that's where the kind of the project is on the video side. I saw one quick question come in the chat here. Can I run a node on a Raspberry Pi? You could, but it would be very unlikely that you would actually win any work and perform any work and earn fees on the network, because the nodes are actually competing to, as quickly and performantly as possible, transcode live video without disrupting the experience. And a Raspberry Pi is kind of unlikely to be able to compete with a GPU in a data center in order to encode that video quickly and performantly in time. Another question here is, can you speak a bit more about how Livepeer smart contracts interact with Swarm and TrueBit? So I mentioned TrueBit is a protocol that's used for basically getting the results of off-chain computation on-chain in a way that can be trusted. And so transcoding is a really heavy computation, requires way more compute than what can be done in a smart contract. So what you want is you want your transcoders to encode a segment of video and then commit to the output of that encoding using just a single hash of data on chain. And then if challenged, you need someone to be a judge. You need someone to be an oracle, essentially, to determine whether this transcoder did the work correctly or whether the challenger was correct. And that's what the TrueBit protocol is designed to do. You can also reperform this computation off-chain, but you can trust that the result that comes back on-chain is correct. And that's through this whole verification game that they've invented in their protocol. And TrueBit's also alpha software. They have a working proof of concept, but we're not yet in production with the full economics incentives around it. And the TrueBit kind of judge provides this trustworthy backstop where you don't have to trust any individual. You can just trust an economic and protocol with a lot of money at stake. And that's how you do kind of the bit exact verification of CPU transcoding on Livepeer. There's other verification methods for non-deterministic transcoding, like GPU transcoding. That's more based on statistics and probabilities. Open research projects on that, and something we're collaborating with other people in the ecosystem on. So different story there. And then with Swarm, Swarm and IPFS are two different decentralized object stores where data can live. The video segments themselves can be made available on IPFS or Swarm for these challenge protocols. And again, those systems need to come to production with guarantees of file availability for this to be truly secure. And so in Streamflow, we have some workarounds where the challenger can just make the data available. And since there's hashes and signatures on it, it can be, can't be contested. So certainly we have this Web3 vision that requires a lot of other pieces to come to fruition, but we blend that with practicality where we're not letting any kind of other projects block Livepeer's actual usefulness to real video developers in the market. Cool. So before I move on to like building on Livepeer and hacking on Livepeer, I want to point out one other aspect of the project, which is the whole token and protocol and blockchain side. So many of the people who interact with Livepeer are not video developers. They're not building video applications at scale. They're node operators and token holders. And what they're doing is, running nodes or staking their token in a delegated stake inspired protocol. So Livepeer is not a consensus protocol. It's not, it's not like an underlying blockchain network, but it is delegated stake based in that you delegate your tokens to node operators who are going to do work on your behalf. And so there's this whole suite of product around that I'll just quickly show off here with another screen share. So hopefully you guys can see my browser here. What we're looking at is the Livepeer transcoder dashboard. And each of these entries that you see is another node on the network. And so you see 30 nodes here. What you see is they're all advertising a few different numbers. They're advertising the commission that they take if you delegate towards them. They're advertising what % of the fees that they collect in ETH that they're going to share back to you if you delegate towards them. They're sharing the price that they're charging for every segment of video that they're encoding. And then you see some other statistics about how they're performing. So you see the the total stake that's delegated towards them in terms of Livepeer token. You see the number of reward calls that they've missed. This is basically every day they're generating their block reward, and you see that many of these are very performant and haven't missed any reward calls. And when you click on one of these nodes and drill in, to wait for the data to load off the blockchain here, do a quick refresh. Right, you see statistics about kind of their performance, their registration, how much is staked towards them. Again, I think this is waiting to catch up. Yeah, it's waiting to catch up and load data from the blockchain, which is a little bit of a slower process. But you can see all sorts of statistics, and then you can use this web app to stake or unstake your token, bond or unbond your tokens towards these nodes, and then withdraw them. So this block explorer kind of shows off how to interact with the protocol. Here's a third-party tool called Scout that gives some statistics about the network. So you can see that there's 12 million tokens. There's about 4 million tokens staked for a 32% participation rate. You can see that there's 13,800 tokens that are being generated today, split only amongst those who are staking, not amongst all tokens. So this kind of high inflation rate is only going to people who are participating. And this is part of the kind of incentives to actually stake your tokens and participate, rather than just hold tokens on the sidelines and get diluted. The whole idea is that this network over a couple of years will be, owned and operated by those who are participating and running nodes and delegating, and not by those who are just kind of speculating, sitting tokens on the side. I mentioned this is a third-party application. It's really nice. They have this whole transaction explorer where you can search for all the events in the protocol and filter them by type and see what's going on. And it's actually, funded through this really nice mechanism called inflation funding, where that application is actually one of these nodes that's running here on the network, and they're funding themselves through this reward cut commission, where they get to keep a % of the inflationary token that are delegated, and they use it to fund the development of their own application, and people in the ecosystem stake towards them in order to kind of help make the ecosystem more useful for everyone, and attract more users. So it's really nice kind of inbuilt funding within the protocol. So let me stop the share here real quick and see if there's any questions. Cool. Okay, so one question is, how do you mitigate the DPoS consensus mechanism from centralizing to large token holders like investors? That's a really good question, and I think that's one of the valid criticisms of DPoS, which is there's sort of this entrenchment where if you own 1% of the tokens on the network and you stake it, then you are going to maintain that 1% ownership almost no matter what. And in fact, you might increase your ownership in the network because not everyone is staked and you're earning more inflation. So that it doesn't necessarily create a centralization, but it does create an entrenchment. Now, there are a couple of the things that also lead to centralization is that there's a limited number of slots right now. There's 30 transcoders on the network, 25 are active. It's small for the alpha. It's going to grow to hundreds in the next upcoming release, but those nodes continue to accrue more delegation, and it becomes a really high barrier entry for someone to kind of surpass the 25th most active transcoder and have enough stake to break into the set. And so what we aim to do in the future releases is dramatically expand this set to encourage competition, to enable a much lower barrier to entry, and then have stake flow towards those who are performing well rather than those who are just essentially entrenched. And in video in particular, there's a couple of decentralizing factors like location, for example. You actually want these nodes globally distributed so that they can have a low latency connection to the application that's sending video their way. And if an application has users all around the world, then you need nodes all around the world in order to serve those users, because what the applications will do is they will immediately fail over to the nodes that are closest to them, that are performing really well, and give the best experience at the lowest price for that particular kind of video point of origin. And so that's a naturally decentralizing force, and leads to people being able to compete on merit and not just kind of entrenched stake on the network. So certainly this is like a challenge in any DPoS system, but I think there's some inbuilt mechanisms that can mitigate it, and we'll all, kind of through protocol governance be working on longer term solutions as well. Cool. Okay, so let's move on to talking about hacking on Livepeer. So I think there's 3 types of hacks that you could consider, and they're all very different. So the first is you could build a video-enabled application, right? And that's most suited to Livepeer. But people who show up to these kind of crypto-enabled hackathons may not be video developers. They may not be oriented around that. So we'll cover what it means to use Livepeer to build a video application quickly. The second type of hack you could build is something kind of on this staking or token or protocol side. And this is what a lot of what the apps around the ecosystem have been kind of built on today, because it's early and a lot of the activity is around kind of the token participation. And then finally, I have some ideas that relate to NuCypher and ways you might be able to combine these projects, which I think would be awesome. But I think there's kind of a high barrier, because you have to learn about 2 projects. You have to learn about the internal workings of Livepeer, not just how to use Livepeer. But this could result in like real production software that actually gets shipped with these projects, and we'd love to like collaborate with people on those. So let's cover these 3 areas pretty quickly. So first of all, I want to do a quick demo of how you might build a video application using Livepeer. And I'm going to do the quick version of this because we have lots of documentation. We're available in the chat room to help out. But the first thing you would do is you would download the Livepeer node. And once you have that, you basically just start it by typing Livepeer, and you choose your network. I'm going to use off-chain mode just because it's going to kind of save bandwidth and be more reliable for this demo. So this is just going to run locally rather than connect to the network. But I've started a Livepeer node. So what that means is I now have this media server that knows how to ingest and serve video and transcode video running on my machine. And now that I have this running, my application can send video to this RTMP endpoint right here. And you can use an existing application like ManyCam on the iPhone or Android Camera on Android. You could use OBS, the Open Broadcasting System. That's what I'm going to use right now. I'm going to just show in the settings here. All I've done is just set my output URL to my kind of the RTMP port that was output here in the node output. And I'm just going to press start streaming. And so right now I'm sending video into my Livepeer node, and then it's going to create this new video stream. It's going to give me an ID. And what I can do now is in the application that I build, whether it's a website or a mobile app, I have a URL that can basically play this video and insert into the application. So I'm going to do this using Safari browser, which supports kind of these video streams natively. And I just construct a URL, also pulling from my node /stream / the manifest ID .m3u8, and this is all covered in the documentation. And there you go. So there's Safari pulling this video. And of course, it's not that interesting just to like play it natively in Safari. What you would want to do is you'd want to build a web app or a mobile app that has a video player in it, and there's plenty of open source ones available. We even have one in our repo that you can download and install, and you would just configure it to pull video from kind of the Livepeer node that you're running. And so that's just a quick start of how you would build a video-enabled application. If you wanted to actually use the network for transcoding, you would run it on-chain mode instead of off-chain mode. You would fund it with some Ether, and then you would have your player be able to use kind of the adaptive bitrate playlist that gets constructed. And that's the short version. So I'm going to flip over to the browser just to show you a couple resources here. One of which is, so our GitHub repository is github.com/livepeer. There's a repository called Broadcaster Chat App. And I'll show a slide later where you can screenshot that has all these resources. This application gives a whole walkthrough of how to get started building an application using Livepeer. It gives you all the code for the example player. It gives you React components for a chat application, so you can build chat alongside your video. And it's a really helpful resource. This is a great getting started point for using building a video application using Livepeer. Let me just stop the streaming because it's spiking my laptop here. Cool. Okay. So the second type of hack that you might want to do is something related to kind of the token and the economics and the staking that I mentioned. So, I showed the example app of Scout. I showed that it kind of outlines the protocol economics, and it shows all the events. I showed the Explorer, which gives you a window into what's going on. But there's so many requests from token holders and delegators in our network of how to make this stuff more useful. People want alerts and notifications around how much they're earning and when their transcoder performs or doesn't perform. They want insight into the fees that are being collected, these sorts of things. And so, there's one example third-party hack that's been built under something called Livepeer.studio, which is like a staking alerts application. And it's a really simple interface. You give an email, you give your Ethereum address, and then you say how frequently you want an email. And then once a week, you get an email about how much you've earned through the Livepeer protocol. And it's already been done. It's really useful, but there's lots of kind of various takes on this that people have requested, whether it's like Telegram bots or frequent alerts when their node went offline when it's supposed to be online, automatic redelegation to maximize returns, portfolio management, everything around kind of token economics that the users find interesting. And if you're looking for ideas there, feel free to pop into our chat room. Finally, the kind of third area of hacks that I was thinking about was just Livepeer plus NuCypher hack. That didn't work. Livepeer plus NuCypher hacks. So what's it mean to combine these two projects? One idea here is use NuCypher to encrypt Livepeer segments of video on a per user basis, so that you could create like a pay-per-view content application where the content's only viewable by those users who happen to have paid at the application level or at the origin. And it's really awesome to think about how this could be crypto enabled and leverage smart contracts or at least digital signatures in order to kind of unlock these payments. And I think that's like a really cool Livepeer plus NuCypher obvious kind of point of integration. The second one I had, this gets a little more technical into Livepeer, but imagine you're an application and you have hundreds of concurrent streams from all different users all around the world, and you need to let nodes, transcoders on the Livepeer network access this content. Well, you could handle all this individual encryption and serving the content to them directly, but oftentimes you might just want to put it all into one object store like IPFS or S3, and you probably don't want it to be public. You probably don't want it to be accessible by everyone, but at the time you write it there, you don't know who the transcoder is going to be that's going to do the work. So the idea here is, write some encrypted content to an object store, and then as you negotiate with transcoders on the Livepeer network, and the software does this under the hood for you, rekey it for decryption by those transcoders so they can do the work and upload the content back to your object store after it's been encoded. So more work to do exploring that, but it's kind of relevant to the internals of our network and a good use case for NuCypher potentially. And then finally, this is the holy grail, and I don't think it's necessarily possible, though I'd love for someone to explore it and prove us wrong. But I believe NuCypher has this concept of fully homomorphic encryption, which means transcoding on video could actually be performed without revealing the underlying video to the node on the network who's doing the work. And this would be amazing. This would solve all the security and privacy issues that may plague certain use cases, but it's so computationally heavy, and this is such a heavy computation to begin with, that it's unlikely that it's directly possible, though it would be amazing if someone could explore what is possible, what the costs are, what the computation requirements are to do this, or to have some interesting take on it that can preserve some level of privacy or plausible deniability using these mechanisms, even if not kind of full privacy. So just a few ideas there. Cool. Okay, so let me jump out of actually, I'll leave the share open for one more second, and I'll come back to the questions in the chat in 1 minute. The last thing I just finally want to show is the developer resources. So this might be a good slide to screenshot, which is kind of where you go to get more information. So you have our GitHub at github.com/livepeer. You have our developer documentation, livepeer.readthedocs.io. Explorer.livepeer.org is the staking and delegation dashboard, so you can kind of learn the inner workings of the protocol. The GitHub broadcaster chat app link has all the example code for getting started building an app on Livepeer. It might be a little out of date, so I definitely recommend the last link, livepeer.org, has a link to our chat room and our forum on Discord where all the developers hang out, and we are there to answer questions and collaborate and share ideas with the whole community. So again, these are good resources. I can paste them in the chat as well, but it might be a good thing to screenshot. So with that, I will stop the presentation. I will paste these resources into the chat. See if that worked. Cool. And it looks like we have a question here. So, do I need specialized hardware to run a node, or can a standard PC participate? So, a standard PC with a high-speed internet connection could potentially win some work from a local node that's near them. It's not really the recommended setup. Again, we're talking about kind of live video here, where you want a super reliable, always-on connection that won't disrupt someone's stream and has enough bandwidth to ensure it can receive and serve that video around the clock. So often this is going to be idle hardware in crypto mining operations, data centers, colo facilities, etc. But anyone can participate without running a node. Any token holder can just delegate towards one of those nodes, and they have very, very low commissions. Like, there's a lot of nodes that have less than 1% commission. So if you're not kind of operating hardware at scale and have a very heavy DevOps spend, you're probably best off just delegating towards those who can. Because again, we're talking about live video here, and it's not going to create a reliable experience for anyone to do live video encoding on a Wi-Fi connection on a laptop that may go offline in any minute. You'll just basically, lose that job and not win future jobs if the reputation is this node's not reliable. Another question here. Ethereum, as it stands today, experiences scaling issues, especially when lots of data is being transacted on the network. Video typically generates lots of data. How does Livepeer solve this issue to avoid bloating the blockchain? Great question. So first of all, no video or video data ever touches the blockchain. That's all transferred on a peer-to-peer network offline. And instead, what the blockchain is used for is depositing the payment that you are going to make for using this network, for claiming that payment when you have done work successfully on the network after you've accrued a lot of kind of built up payment to kind of cash it all in at one time. And we do that using a mechanism called probabilistic micropayments. It's kind of interesting. It's like a different take on kind of payment channel ideas where you pay kind of with lottery tickets that often lose and you pay nothing, but the probabilities are that eventually they will win and kind of have a high face value, and it'll lead to like one big payment that averages out to all that you owed for all the work that you've done over time. And then again, the blockchain also provides the security layer such that if anyone tried to get paid for work they didn't do or didn't do correctly, the blockchain can adjudicate that and slash them and cause significant economic harm if they did cheat, and ensure that no one pays for service that wasn't provided. So, you know, that's kind of what the blockchain is used for, as well as all the staking, delegation, token rewards. And in the first version, the alpha, there were a lot of Ethereum scaling issues. It didn't get in the way of video work being done, but it did create a lot of extra costs in order to prove this work correctly and to cash in your payments. And so this was before we introduced the micropayments concept. Basically, these 5 updates that we made to address these issues are bundled together in something called Streamflow. It's the next big release. You can read all about it in our research on GitHub. And this removes all kind of cost dependencies on the blockchain, or it reduces them down to a very low percentage of the actual use of the network. So definitely necessary updates to deal with Ethereum scaling issues, but we're not bloating the blockchain, or we don't require many, many transactions in order to make this network usable for video developers.
All right, we're closing up on like 40 minutes here. Doug, thank you so much for your time today. This was an awesome presentation. I know I got a lot out of it. I know the hackers did as well. I know you provided some documentation that people can visit. Where can people stay up to date on all things Livepeer and follow you as well?
Awesome. Yeah, you can follow us at livepeer.org on Twitter. And if you go to livepeer.org, you'll see links to our forum and developer chat room on Discord. The chat room and forum are really active. Developers hang out there, node operators, transcoders. And so just pop in, say hello. We're all there and happy to help anytime.
Awesome. Thank you so much, Doug.
Yep. Thanks for hosting. Thanks to everyone for attending. We'll see you later.
Have a great day.